Hello guys, I'm Pranav. I work at EdgeNode, which is one of the core devs of the Graph ecosystem, and I'm really happy to be uh, representing the Graph ecosystem at Upbit's annual summit, which is UDC. I'm really happy to be talking about Firehose, which is one of the latest inventions of the Graph ecosystem coming from Streaming Fast, the other core dev. I'll be telling you what the Graph does, what are the challenges that indexing faces, and then how Firehose and the latest substream stack actually tries to solve for some of the high performance issues that subgraphs might not be able to take in. So without further ado, let's share my screen and let's start talking. So to start with, we'll first of all understand what what is the graph. The graph basically has been indexing blockchain data for a while. It is the go-to solution for Web3 indexing. And the graph, EdgeNode, the initial team behind the graph and now CoreDev, was the one to build the graph node. And using graph node, what you could do is you have smart contract, which have events. You could listen to those events, create subgraphs, and have great GraphQL APIs to have those informations that is required. And many top decentralized applications, the Aves of the world, the Uniswaps, and the foundations, the NFT marketplaces around the world, use the graph to index the smart contract data and get their information in their own hand, right? But there are a few few things that we have to consider while we have this indexing approach. Indexing happens in a ETLQ format. This is same for Web2. This is same for Web3. In Web2 as well, we have the current indexing solution, which is like ETLQ, which is extract from the RPC information from the blockchain, transform that rough RPC, raw data of the RPC, and load it into a Postgres or any kind of database, and then query it. How Subgraph does it is basically get information from a RPC or run a full node, then transform it using the Subgraph code that you guys have written, and then load it into Postgres so that it is queryable whenever required on demand, right? And this has a few issues. The first issue is latency. The reason behind that is because ETLQ is a linear process. The way you index information is in a very, very linear format, and that has its own issues. For example, if you have a very, very fast chain like Polygon or BSC, which are also big and fast, it's very tough for the RPC to be very quick to serve you, first of all, that data, right? And secondly, once you have that data, to transform it in a very, very quick and fast manner. It's very, very tough. And that's why, there might be some really, really high performant dApps which are deployed on really fast chains and have a transaction in every block. It's very tough to have that process being linked and the subgraph being synced 100% for that. The second biggest thing, as you might have already thought about, is that if you have this kind of ETLQ structure, you are actually getting information from RPC. In a way, you are again and again going to the RPC for the information, which makes it really, really costly. Secondly, if you are getting that data and storing it for every subgraph that you create. For example, I create a Lido subgraph and I create another Lido subgraph with a different IPFS hash. I'll have to redo and restore all the same information in a different place at the graph node. So it is a lot of repetitive data. It's very expensive, and the RPC, RPC request that graph node has to send is also in a big good number, which causes the cost to be really high. Thirdly, the reliability is a little less because, as I told you, that the latency might not work out, as well as the chains might be a little fast. And given that it's a linear process, the performance is not the best. Again, the graph node was created for EVM chains, and that's why it's not chain agnostic, right? It's specifically for Ethereum virtual machines. And there can be hacks to support it for other chains, but there would be hacks. It would not be the wholesome, complete solution. And that's what causes the issue with chain, with other chains and other VMs, so that the ecosystem doesn't grow. It is stated in that own VM, right? That's the bigger problem. The first part of the solution to that is that you need to actually, to get the indexing to solve all these issues, you need to work out and experiment as well as innovate on all the few following layers. You need to experiment on extraction, you need to research on transformation, you need to innovate on load as well and query as well. The first part of the whole ETLQ, which is extraction, is what Firehose innovates on. Instead of relying on RPCs for getting the information or running big, huge full nodes of Solanas and Polygons, which are at 1 TB and very tough to run, you rather have Firehose, which have simple, crazy flat files to get the information. What is Firehose for that? First of all, Firehose is flat files. Instead of getting the information from RPC and keep on getting the same information again and again, somebody else requests it, you have the full node to serve you flat file, and that flat file is where you can get the information, very, very granular kind of information. So instead of going again and again to the full node or RPC, you have a flat file which has stored that blockchain data in the most granular format to get the information. Secondly, given that it's flat file and the information is already stored in flat structures, it is possible to enable parallel computing. The bigger problem with subgraphs was that it is linear computing, and with something like Firehose, it enables parallel computing. Something we'll see in the coming slides of mine. And the third thing, the most important one, is that it's VM agnostic. What that means is that it doesn't depend which chain client it is. If that chain client is Firehose compatible, then we can index the information in the most the way we want to. It's not like the graph node is only compatible with EVM. It's rather with Firehose, you enable your stack to be compatible with a new set of things that we'll be discussing. So it is EVM agnostics. Even Solana will work for this. Even Ethereum will work for this. Every other chain graph node client will work for this, given that you make the chains that are inside the chain client for the same. The biggest achievement of Firehose, we'll be talking as to why you should look into Firehose as a new paradigm to get information from the blockchain. But before that, the biggest, but we need to give you some proofs that why is it the right kind of solution, what is the things that Firehose actually enables. And the solution to, or the answer to that is that it enables the second piece of the ETLQ indexing format, which is substreams. Substreams is transformation layer of the ETLQ innovation. ETLQ is simple, right? With subgraphs, we have been doing ETLQ in linear format. There have been performance issues related to that. Extraction is actually innovated via Firehose and flat files. And the second biggest thing is innovating on the transformation. Instead of going through assembly script and subgraphs, you go through something much more high performant with Rust substreams, right? And substreams have that amazing feature of caching as well as transformed data, right? What that means is that instead of getting information from subgraphs, you get it from streams, different streams, which actually give you the most granular data. Subgraphs can actually only index events, and that's another issue with subgraphs in a way, right? That they can only index events. If I send a transaction from my address to another address, that cannot be indexed with subgraphs. Rather, it is only possible to index that with something like substreams, right? And that's the bigger innovation. Firehose is the data source for substreams, and substreams only listen to flat files by Firehose, right? If you have your chain client, may it be Solana, Near, EVM, Polygon, whatever, Starkware, whatever it may be, that information, that chain client, if it has Firehose, it will give you flat file data structures. This is something that substreams can read and do the rest of the indexing process. So this is not just EVM, but innovation all across Web3, right? And what are some of the performance metrics that we have taken to say that substreams are better than subgraphs? Is because we actually ran a test on the Uniswap subgraph, for example, and we were able to get a really good we were able to get a really good performance timeline. Instead of it reviews the syncing speed of something like so the syncing speed of subgraph from, let's say, 2 weeks to 20 hours, right? Because of parallel processing, flat files, and Rust based streams that are created. The architecture of Substream actually looks like you have Firehose enabled graph node that gets information to Substream service, which at the end you will be creating, it's a data sink. The Substream is a data sink, which at the end will be creating an API. That API is something that people can look into and get the information from, right? Firehose enabled blockchain node gets information into Substream, right? Which at the end gives you the information in the API, right? So that's how this works. The architecture, I'll not be going into detail as to how substreams work, but this is your Firehose enabled RPC. We call it the gRPC, right? You have the Firehose enabled, full node that creates this Firehose gRPC. From there, the substream will be taking the information. The latest block will be created into a block file that the reader will be listening to. If that block file is not required, you need to store the information. There's the object store, which actually creates an index and stores the information in the most optimized way possible. And already there are dApps that are working on it. There is a subgraph deployed by Misari called Uniswap Substream Subgraph Misari. Subgraph on the Graph Explorer. You should go and check that out, how granular it is as compared to Subgraph. Also, Balancer and PancakeSwap have been running on production on Substreams for a while. So this is a better, like a newer technology. I would not say that subgraphs are not the right way to index blockchain data, right? They are great, and they have been the industry and ecosystems paradigm, as well as the standard for indexing blockchain data. But for if you need something much more performant, then you might want to use something like Uniswap. You might want to use something like Substreams. If you have a really fast DEX, for example, like QuickSwap on Polygon, then you might want to consider something like Substreams and building streams for your Substreams data and getting a sink on top of it, which is like GraphQL based subgraph or something like that, to get that information in the right way. And that's what PancakeSwap did for their indexing needs, given that BSC was a very fast chain and their information was stored in all the blocks in a way, right? And Firehose, again, is the first innovation in the ETLQ process. And Firehose not just enables substreams, but has more to it. For example, we ourselves have been using Firehose and EVM executor instead of RPCs for our hosted service needs. And it has been serving 5 chains, about 8K subgraphs in total, and 27 billion queries a day. And it never, falls sick. RPCs might actually lose on transactions. It might just we might not be able to see some transactions. There might be times when the RPC node is down, but Firehose will never be down, given that it is a flat file that is created, the most optimized flat file that people can look and get the information from. dApps can look and get information from. Other than these RPC needs, it also solves for the tracer. I covered the reduced RPC cost by using Firehose EVMX as a solution. The other thing is the trace filter, right? You can use the trace filter, there are few get nodes or get forks in blockchains, so they don't have trace filter calls. With Firehose, you can enable trace filter as well if you upstream the Firehose capabilities in your chain client, right? Again, it's integrable across chains, given that Firehose is a standard. So it's not just a standard for EVM chains, but also all across Solana, Flow, all these chains. They just need to include the Firehose capabilities in their chain client, and they will become substreams indexable, as well as they will have this whole ecosystem for indexing their own needs. So the CTA to everybody, or all the people who are running chains at least, is that they should look into the Firehose tech and upstream the Firehose files inside their chain client binary, so that substreams can power and support them, right? In our opinion, Firehose will be the new standard for indexing blockchain data, right? As well as for getting information from the blockchain. So yeah, let's try to build it together. There are enough proofs to tell you that we have already started building on it. There is ChainSafe, which is one of the co-devs of the graph of Ethereum as well. They have converted the Aragon client to be Firehose compatible. It's not upstream to master branch, but this is something as an ongoing process. And there is a fork that Aragon Firehose is maintained by ChainSafe people. That's one. The second thing, other than that, is that already integrated chains with Firehose include the Ethereum's Aragon, Go Ethereum, BSC, Polygon. All these are Firehose compatible chain clients. So they are substreams compatible as well. They all have trace filters in them. They can have a solution other than the RPCs with the Firehose EVMX solution, as well as non-EVM chains like Near, Solana, Starknet, and Aptos are Near and Solana are already live, and Aptos and Starknet are working towards having Firehose chain clients so that they can also be indexed via substreams. I hope you understood the whole topic. I'm Pranav. I am a senior solutions architect at Edge and Node. I look at oversee chain integrations and other things around Asia markets. I'm really happy to be presenting at the UDC conference, and that's about me. Thank you.